issues. So right now, we are taking a look at the sheet that you guys did yesterday, this sucker right here. And I need you to draw your attention, please, to the back of the sheet. Yes, did you have a question? Yeah, have it all in the pile because I'll just pass it over rather than stamping it. All right, perfect. Let's go ahead and get this thing done. Ladies and gentlemen, you're looking at your pictures of the stuff that you drew in the cup. And I think this class did really well. I had some classes that never got to the drawing, stuff like that. We'll get you a copy in a minute. Okay? We have some kids that never got to the drawing, and I think that in this class most kids got to the prediction, and a lot of kids also put them in water. So what we're going to do is we're going to have kind of an upper-level conversation using this tank that we have up here. Right up here, I got 7 items in the water. Okay, you might, if you're in the back, you might need to stand up. There's nothing really major to see here, but we do have 7 items hanging out in the water. You had 4 of these items, the ones that I have up here. All of you had items that sunk. You guys either had two different types of metal here. You had one of these or both of these. Some of you guys had one of these 2 types of plastic. Now, except for you guys had your own special situation yesterday, which is kind of cool. You had one of these 2 types of plastic, maybe a different type of plastic, and all 4 of these items all have densities greater than 1. They're like 1.5, or they might be like 7.9 or something like that. So all these suckers are sinkers. These 2 items here, and this was your item over here. Just curious, is that yours? Did you guys have this one? Yeah, I'm going to take that one and set it out. All you guys had these 2 things right here. Check it out. Take a look really carefully. They're floating on top. You should be able to see them. If you look at them really carefully, you'll realize that they do not float the same way. You see what I'm talking about? Mm-hmm. Now, here's the question. A lot of you guys really got the hang of this at the end of yesterday's class. Which one of those... let's do it this way. I like this question. I'm going to hit you with an upper-level question right in the beginning. What do these 2 densities have in common, and how are they different? Let's talk about starting with an upper-level question. What do these 2 densities have in common, and how are they different? So it's a compare and contrast question. I'm psyched by how many people have their hands in there. All right, you want to start with what they have in common? We could do that. That might be a good way to go. What do these densities have in common? What do they have in common? They're both less than 1. Definitely agreed. All those guys down on the bottom, densities are greater than 1. These 2 hanging out here, both less than 1. So they're both going to be 0 point something. We don't know what. How are their densities different? How are they different from... Oh, did you have another thing you were going to say about them being in common?
No.
Okay. How are their densities different then? What's different about them? What's different about them?
The one that is like the diamond, the density is probably less than the one that's just barely floating. Yeah,
than the one that's just barely floating. So this one right here has a density that's less than this one right here. All right, guess what? I'll be honest. That right there is an upper-level concept. And I'll tell you right now, I can tell from looking at you, most of you get that without any problem. You're like, that's easy. They're both less than 1, but this one's less than that, so it floats higher. So let me hit you with something that's substantially higher level than 8th grade. Ready? Watch. You can tell exactly what the density is just by looking at it, like a number in your head. Okay? For example, you all had a piece of pine. Now, pine is different than, like some pine is different. This has a lot of knots in it. Can you see the dark wood in there? This is probably a little bit more dense than the pine that you had. It's pine from like a pine tree. Okay? This is pine right here. Now, the density of pine, this pine right here, is about 0.6. Right there. That's about 0.6 for its density. They might find their pine to be about 0.6 or 0.5. Yours might be less dense. What did you guys find? 0.5. 0.5. Anybody else find something around 0.5 or 0.6? What did you guys find? 0.6. So check that out. Now, we're going to go ahead and it said 0.7? Yeah, this one might be close to 0.7 too. Now, the reason why I can tell it's got a density of around let's say 7. The reason I can tell is because of the way it's floating. What? What are you going to say? Go ahead.
Like, it would like be 5, like, it'd be like right on the line, and then, like, but it's not, it's like over the line, and there's like...
Yes, I know exactly what if you could see her, she's freaking out. She's like, it's like over the line, and there's like, if it were 5, it'd be like, I think she blessed me at one point. Thank you. That was good. Yes! Whatever she said was right. It wasn't like in English, it was kind of an alien language, but it was. Here's what she's saying, and here's what she started by saying. Well, if it were 0.5, it'd probably float like that. Is that what you're saying, like right in the middle?
Yeah.
Yes, if it had a density of 0.5, half of it would be above, and half of it would be below. But, yeah, there we go. So now your brain should start to wrap around. That's about 0.7. Because, this is messed up, so make sure you listen, about 0.7 of it is below the water. Does that make sense to you?
Mm-hmm.
And about, how much is above?
3.3.
Yeah, 0.3. So now you can do that with anything. Look at, without even trying, you can take something, throw it in water, and you can see what the density is. Oh, that's got about like a little less than half of it above the water, and about, so like let's say it's 60-40. 60% below, 40% above. That means the density of this thing is 0.6, roughly just by looking at it. So what do you think the density of this one is then?
9.
Just look at it. Just look at it. Now you don't even need to look at your mat. You don't even need to look at your mat. Just take a look at that. What do you think? Just curious. What do you think? Just by looking at it, how much above, how much below? You know it's going to be 0 point something, so what do you think the density is going to be? Yeah, you were saying you were going to get it, so go.
Yeah, 0.9.
Like 0.9, yeah, we got like most of it underneath the water, like 9/10 of it with 1/10 of it above. It might even be a little less than that. These guys over here have this one. I don't know if you can see this or not. This thing right here has a density of about 0.95, which means it's going to float, but it's barely going to float. This thing is going to have 95% of it below the surface of the water and about 5% sticking out the top. Okay? So you see, that's the lowest floater we got. Okay? You can definitely tell that by looking at it. In fact, it's almost to the point where it's not even busting the surface at all. What about something like a beach ball? You ever see a beach ball? Yeah, does a beach ball go far into the water? You drop it in the pool, so you have, when the wind blows, it's like, it goes blowing across your pool. Yeah, it's like, it might not even be 0.2. It might be like 0.1 and 0.9.
Like the little part of the bottom of the ball would be like touching the water.
Yeah, that's
and then
it.
it'll be up here.
Yeah, so when you draw wood like floating, don't draw it like that. I love it because my wood floats. And you draw it like this. Wood does not float like that, okay? Only humans float like that. Like beach balls float like that, Jesus floats like that. Okay? But you do not have wood floating like that. So when some of you guys were drawing stuff, okay, you're not drawing, oh wow, we have Play-Doh. We have 2 references. Awesome. Yeah, when you're drawing wood and stuff, you want to make sure that you have appropriate amounts above and below the water, which is going to bridge us into the next thing that we're going to talk about now is how you can make things float that have densities greater than 1, which is pretty cool. We should have enough time without any problems, so I say take it. I'll take this question over here as we're messing around.